Good afternoon, everyone. It's a very lovely day to host our online live session today. And our presenter today will be Rodrigue from Burkina Faso. Rodrigue has a large experience in minerals and natural resource management, has been working for various institutions from Australia, the whole continent of Africa, and currently he expresses interest in using the Africa platforms, especially to monitor water dams in Burkina Faso. He's currently a PhD student at the University Joseph Kizeribo. Rodrigue, over to you, sir.
Joseph, and thank you to all the participants. Today, we are going to present once more the water monitoring using the Digital Health Africa. The time to share my screen. Okay, that's fine.
Yes, now you can see your screen. Could you go to the presentation mode? Now it's okay. Yeah, thank you.
Okay, that's
Thanks,
fine. Okay, so as I was saying, today presentation is about the water extent monitoring in dams using the Digital Health Africa tools. As we said, water resources, the surface water resources is shown as the form of the water, the best form of the water to access the human, the living creature. And the United Nations agenda has defined 17 sustainable development goals, in which the number 6 guarantee access to water and sanitation for all and ensure sustainable management of water resources. In its indicator 6.6, it states that by 2020, it should protect and restore water-related ecosystem, including mountain forests, wetland, rivers, aquifers, and lakes. In the sub-indicator stating the extent of water-related ecosystem has 4 themes. The first is the spatial extent of water-related ecosystem. The second is the quantity of water contained within this ecosystem. The third is the water quality within those ecosystems. And the fourth is the health of state of those ecosystems. So we are interested of the first one, which is the spatial extent of water-related ecosystem. And that one is in Burkina Faso, which is this country of Sahel, located between Mali, Niger, Benin, Togo, Ghana, and Cote d'Ivoire. Burkina Faso has about 22 million inhabitants, and its economic growth has slowed from 6.9% in 2021 to 3.2% in 2022. And because of the sector of the extractive that have decreased a lot due to the pressure of the crisis. That pressure is the same with the climate change, which is affecting water resources. Given that its resources, its surface water resources are stored in rivers, lakes, and dams. And it is used for drinking water, for agriculture, for hydropower, for watering animal, and for tourism and leisure. What happened to the water extent and in dam and lakes during the periods of climate and security crisis now in Burkina Faso. So we have followed that soften of the indicator of the soft indicator 6.6.1, which is the spatial extent of water related ecosystem, in which in accordance to that term, we conducted the study on about 32 dams and lakes in Burkina Faso during the period from December 2016 to June 2023. And the study was done, as we're saying, with the Digital It's Africa tools. These are the table displaying all the dam that we have passed through. What is the Digital It's Africa tools? On this slide, you can see how the Earth is being observed by the satellite, and the data can be stored in an open data cube owned by the space agencies, which provides analysis ready data to show that can retrieve this information. We have some example in our right. So the Digital It's Africa tools is completely free, and even for commercial use, it is optimized for Earth observation data, incorporated for wet processing, completed visibility that give a complete visibility from the data to the products, the different interface of different needs, that is free online, that have free online learning platform and help desks that can be that have an intensive library for sustainable development oriented tools, and each one can build a complex analysis based on his own topics. So Digital It's Africa has a lot of diversified notebook in his library. Today we have more than 69 open source notebook touching about 7 main topics, and those topics can be grouped in the agriculture, food security, water resources and floods, vegetation, urbanization, land degradation and land cover and accounting, coastal, marine and environment, as well as Earth observation data. Those analysis ready satellite data sets include Sentinel-2, Landsat-7, Landsat Sentinel-1, and SRTM Digital 11 model, as well as alloys an annual mosaic. So these are some few characteristics about those satellite that is used for the Digital It's Africa tools. And the one we use for our analysis is Sentinel-2, which have a spectral band that can detect the presence or the non-presence of water. And those bands are indexed into the modified normalized difference water index, which is MNDIW, that allow access to storage capacity of dam, detect abnormal variation of or leaks, predict flood risk, observe visible change in the contour of water bodies such as cracks and subsidence, and can be identified using high resolution optical image. Sentinel-2 also contribute to the sustainable management of water resources and the prevention of risk linked to dam. The MNDWI use the band green and the shortwave infrared spectral band according to the equation below. So, what result have we retrieved from this study? Some important information on surface water resources can be can create situations ranging from economic losses to disastrous foods. The typical case is the Kompienga hydroelectric dam located in the eastern region of Burkina Faso. And data processing displayed a set of metadata based on the MNDWIL value categorized as below. So we have the essential outputs. Essential outputs is such like the band that can be extracted, the index that can the indexing, the reference carbon, the system of the reference coordinates, the map grids, the processing that is done on those data. And then concerning the variable outputs, they are organized in 3 levels. The first one is the water body area maps. And the second one is the group of water body area variation graphs. And the third one is the water body area map that show the gain and loss of the water area. The first one, as we said, is the Kompienga hydroelectric dam, which is here. On this map, we can see this month. So this is the first line is the year, is from the December 2016 to September 2017. So we have here the month of December. Are you seeing my arrow?
Yes, sir, we can see.
Okay, thank you. So this map is the map of the water extent in December 2016. Then we move to the March 2017. Then we move to the, this is March, this is June 2016. And then we move to September 2016. This is the year 2018. This is the year 2019, 2020, 2021, 2022, and here is the 2023. What we can see is that in June, the water body seemed to be the narrower parts, and it is increasing from 2017 to 2023. So now the question is, we realize that from September 2022, we have the same shape. December 2022, no, this is September 2022, March 20, sorry, this is September 2022, this is December 2022, this is March 2023, which seem to be in which the water bodies seem to be similar. So there is no much change. And we are here in June 2023. and the water body still be with the same extent, like the four previous quartile. So from there, we have the trend. We see that the trend is the same like in other lake and dam, like we saw in the lake dam 2, the lake Bilmiugu, the lake Yetamga, the lake Makoy, the lake Jibo, Kanazoe, the lake Guti, and Nyam Bolandi, that we could not be able to show all the image on this map. The second result is the water body area variation graph. What we were saying is that in this graph, we have the year at the x-axis, and we have the area of the water body on the y-axis. So we have a large peak here. This one, the large peak is September, and the low peak is March to June. So what we're seeing in the previous map is that in September 2023, we have the large water body. So the area of the water is the highest. But we are expecting that in March or June 2023, that this should be down. But we are surprised that the water have not changed significantly into the dam. And in the next September, it's true, we did this analysis before the data was not ready for the month of September. So we are expecting that in September 2020, the water, this line will be coming here and might increase the water extent and might double the water extent into the lake. So from there, we try to talk to those who are managing, the company who are managing that dam, to let them see what can happen, like floods or the dam break. So the third result is the water body area, map that show the gain or the loss of the water during the time of the analysis. So it's appear that here in Kompienga, the green is the no water to water. So the places where there were no water and that have a water now, that is estimated to 82 kilometers square, while the permanent water is 102 kilometers square. So this means the no water to water is almost is more than a half of the permanent water in the dam. So the water is spraying during the last 7 years. Why the water is spraying? So something is happening. We just understand that if the water is spraying, we can understand that people were farming in those places, and that their farm should be inside the water now. And if the water is increasing, we can assume that soon the water will cross the dam. And if the quantity is more than what the dam can contain, it can break the dam. But we also have some few cases, like in the dam of Lumbila and Suma. This is the dam of Suma, and this is the dam of Lumbila. So we realized there that the water extent is reducing. We have on about four cases like this one over the 32 dams that we have studied. So the consequence is, as we said, when we saw this type of information, we go deeper and realize that some imaging in some imaging we could see how the dam is the water is crossing the dam because of overflowing. Like the case of Litubu here, in 2014. Okay, we can have some demonstration if the platform, we can access the platform.
Yes, sir. You can access it now.
Okay, that's fine. Let me stop share here and then share another one. Okay, I hope you are seeing my screen.
Yes, sir. Can you see it? Thank you.
Okay, thank you. So we have the water extent of in the Compiègne notebook here. As usual, we load the packages. I have already run the notebook as it took a lot of as it took time, so that we can be we will not lose time while waiting for the notebook to be executed. So these are the package that have been loaded, and then the data cube is loaded. Then the dash chunk to reduce the memory that is used, and then we have set our area and the time. So the time here is from December, is from 2017, but we requested to start in each December. So then when we run this one, is give us the map of the area. With this area, we have managed with the buffer to have the square on the area that we need to analyze. Then we move to the processing. This is the code that have to extract to start process the data, and then this is the result after processing. Especially for this dam, we see that within the time we have over 440 time that the satellite cover the area, and we have the X and Y images, the number of pixels. We have the band that has been extracted, which is the green band for each image, and then the shortwave infrared number 1. And we have the data like the coordinate reference system, and then the grids of the map. And now we start process the data that have been extracted, and then calculate the modify the modified normalized different water index using the mission of satellite Sentinel-2. And then when we process, this is where we request the algorithm to start from the month of December. And this is what appear using the plot of the modified normalized water different water index. And then we can have this animated image. And from then we have another code here, which is set to extract the resolution for the area. Then this is used to calculate the extent of the water. And from there we plot. The plot gave us this graph. And as we were saying, this point normally need to be down, more down than here. And to determine the evolution of the water with the time, this code is set, and then when it is plotted, no, this is to compare the two seasons. The maximum extent appear in September 2022, and the small period of small extent appear to be in March 2017. Then we can also compare two periods on the same time. We have decided to compare here the March 2023 and December 2026. And what we were saying was that in March normally the water body should be narrow compared to December. So this is a problem in that dam. And then when we goes into, we use the other codes to plot the evolution of the water in the dam. And this is where we realize that the water is overflowing some area around the permanent water body. So we have also the other ones, but we give to the time we will not stay alone here. Yeah, this is the Bagre Dam. It also gave some information. And then we'll stop like this and come back to our slide. And just to say thank you to all the partner of Digital Aids Africa. We have Afrigis here and much of partner. And then thank you very much for your time and your kind attention.
Thank you, Lodig, for your very nice presentation, very pedagogic. You were able to share everything related to dams monitoring in Burkina Faso. The notebook is available for everyone via our sandbox. I haven't shared a link to our GT repository when you can see everything. Someone called Ave Maria is asking if we can share the presentation. Yes, please, we share it. It's yours. You get it soon. Allow me to thank everyone Also, if there is any question intervention, but let me acknowledge most of our guests, especially Andre, our VIP, one of our big advisors from the African Union Commission. Over to you, Andre, if we can say hello to our participants. Thank you.
Good afternoon, Joseph, and uh, good afternoon, good morning to each and everyone. I was listening uh, with great interest to the presentation made by Rodrigue, and it's a very useful and interesting um, presentations on how we can use some of the resources from Digital Earth Africa to monitor the multi-temporal change or change of African surface water bodies, which is critically important, not only at the local level, but I want to emphasize also at the policy levels, because we need to have this kind of information to better frame some of the policy we want to develop. Therefore, my question is about how can we replicate this work made on some selected dams or water body in Burkina Faso to um, generalize it at the continent level so that we can have this kind of informations. I might say um, every quarter, because you have worked quarter by quarter, but it might be even enough to have it every year, and knowing how our reservoirs and water bodies are evolving over time, which can help policymakers to define some policy response if there is a crisis, or hopefully maybe some of them may expand over time, and this might be also trigger economic activity around this water body. So thank you so much again, Rodrigue, for a very good presentation. We look forward to appraising this kind of methodology, techniques, and all the apps and solutions that are beyond to make it happen in a regular basis. Thank you, and over to you, Joseph.
Thank you much, Andre. Let me mention that you are among people who support Digital Africa in our everyday's work, and we are very grateful to have you on board today. Logic, do you like to react on the question from Andre, or let me react on it? Logic.
Yes, thank you very much. Thank you to Andre for his concern. Yeah, it's possible. It's here. This is just a demonstration. So based on the case that we need to observe, we can remodulate modify the code to allow to get the result that we need. We can decide to have the results maybe just each week, given that the satellite you are using have a data cross the area, is Sentinel-2 that cross the area every 5 days. So data are available every 5 days. If the satellite succeed to capture the image without the clouds, it's possible to have the data every 5 days. And then we can combine into 10 days, we can combine into a month or 3 months or 5 months or a year. So it's possible to do that. It's depending on the satellite data time sets.
Thank you, Rodrigo. Actually, what I can add on is that the Africa developed the notebooks, they're already available. We can either upgrade them or even customize depending upon the use, adding more indices or duplicating it or in various areas. And with Rodrigo, the use case once completed, we have a repository on our sandbox where we put some successful use cases so that people could benefit from the codes, even the methodology, so that could be replicated in any other regions. So it's definitely in whatever we do, whether it could be replicated because a scientific methodology well documented should definitely be duplicated to other areas. Thank you, Andre, and also Omindi, Omidiji Jokolota, over to you. I saw that you raised your hand.
Yeah. Hi, everyone. Can you hear me?
Yes, we can.
Yes. Thank you. Thank you for the wonderful presentation. I'd like to ask a couple of questions. If we could go back to your slide that the presenter was sharing some of the slides, those on the water extents for the different dams.
Water extents and different dams.
Yes.
A moment. You see the slide for my side?
Yes. Yes.
A moment, please. If I like the representative, this one?
No, yes, this one.
This one, yeah.
No, the maps before.
This one?
Yes. From the presentation that you gave to us, you were talking about some uncertainties, or let me say abnormalities with the water extents for some periods. How do we deal with uncertainties when we are not sure why there is an increase in water extent? Do we just rely on this data that we get from the sandbox? That's the first question. How do we deal with uncertainties when you think for a particular season, like let's assume December or March, there is supposed, in all likelihood, there is supposed to be like a reduced water extent because it's the dry season, and then you're having higher water extent during that time, and September you're getting lower area coverage for water. How do you deal with those uncertainties? And is does the algorithm kind of like take into consideration tidal fluctuations? How are these maps generated? Do they take into consideration the high tide and low tide? The second question is a comparison of the different maps from the different sites that you used. I could see that the dam is responding to environmental and even climatic variabilities. Is there a way using the sandbox that I would be able to link it to either rainfall or if it's temperature in terms of maybe drought or reduced water extents? How can I incorporate those techniques together within a particular notebook, or do I need to do it one by one? Those are my questions.
Thank you, Jokolota. Over to Rodi. The floor is yours. Maybe I couldn't even after.
Thank you very much for the questions. The first one, I will just say, how do we do for the uncertainty? So it's true that when we were developing when we were carrying on this study, the idea first was to see how the water extent is behaving. So now we see that the general trend in Burkina Faso, the water extent in all surface water is being increasing. This is the general trend from during the last 7 years we have used to analyze. And now the problem first is to see what can be the problem. What can be the problem within that water that can caused by the water extent in Burkina Faso. So we identify that floods can happen. But now, why is the water extent is increasing? So we understand that many factors can happen for the water extent to increase. For instance, the sedimentation into lakes and dam. We cannot avoid the sedimentation, but when we see the rate of the water extent, we can now try to see if the problem is the increasing of the water in the dam, or the increasing of the sediment which is settled into the dam and pushing the water on the top. So these are the elements that we are trying to see now. And another notebook is being developed to solve to try to understand what is going there. So this was like an informative study before continue to see what is happening there, because there is a lot of consequences that can that are related to this situation, which is not only the problem, because if water extent increase because of the increasement of the water inside the dam, that can be positive for the people who are, for the dams that have been built for agriculture. So just to say, I'm trying to develop the other notebook to see really what is going on. Now, coming to the second question about the comparison of the link of the water extent to the other factor like the rain. Yes, I have worked with some Digital Earth Africa technicians to try to add the water, the temperature, the raining and the temperature on the water extent to see what is going on. I will show you the notebook, the result that we have now, but which is not only finished. I need to open that notebook to show you what is going there, and then I will be back to you. The time to give back the speech to the moderator, Joseph. I will be back to you soon with that notebook. Thank you.
Thank you very much, Rodrigue. The question was that what I can add on is that to do the certainties, whenever I use Earth observation data sets, we need to go to the field for validation, and that's where I could create knowledge for people living there, but also try to see what was happening around, which years the wreck was increasing in size, and which years the water table was reduced. Okay, thank you very much. Also, Anis Gatasi from OSS.
Good morning, Joseph.
Yes, good morning.
Joseph?
Yes, sir, I could hear you.
Good morning.
Could you switch on your video? That everyone could see that. Great.
First of all, thank you for this presentation. I congratulate Rodrigue for this presentation. But I think that using the determination of decisional extent for of water bodies for the spatial extent, like the quantity water contained within the ecosystems and the quality of water within the ecosystems. But we can also use this kind of or such applications for other studies, like the studying of the urban areas, during the urban areas state regard when or during the flooding or due the climate changes or rising urbanizations, and maybe when we have an inadequate stormwater, for example, it could be useful for the stormwater management. So, by the way, I have some questions for Rodrigue regarding. The first one is what are the key steps involved in processing and analyzing Sentinel-2 data for this case of studies? And the second one, what are the some advances, maybe images processing techniques uh, at his opinion regarding the that could be employed by Digital Africa to enhance water extent mapping accuracy in dams, like the case of studies that he talked about. And the last question is about so even for even I asked this question to you, Joseph, and of course Rodrigue, is how does Digital Africa validate the accuracy of water extent mapping results derived from Sentinel-2 data in dams? Thank you.
Thanks, Gatasi. Let me add that you are part of OSS, one of my main partners, and have contributed a lot to our works. Thank you for raising those few questions. Over to you, Rodrigue.
Okay, thank you very much, Anis. These are some bright questions, and I think it's really techniques. The steps, the key step of the analysis of the water extent. Yeah, I think the notebook, the notebook has been. Let us go back to the notebook itself. If I can I share it again? Can you see my screen?
Yes, you can.
Yes.
Okay, so I have this. Please, just to complete the previous question, as I was saying, something happened to the discourse. As I was saying, we are trying to display the water, the rain on the water extent and the temperature. It's not appearing fine, but I say it's not yet finished. But this is what we are trying to do, to try to see how the rain is behaving, as well as sediment in those dam and lake. So maybe by the end of this month, we'll try to have some exercise like this to see this is the temperature, this is the rain, and this is the water extent. So we are not. I am not a a code writer, so I'm working with the code writer of Digital Africa to try to explain, as the question arises, what kind of resource we need, and then try to see how we can work together to get those results. So I think the previous questions who was asked about the link of those parameters is completed now. Now, coming to Anis with the key steps, we just start by define what we need and try to see what kind of image, what kind of satellite image will be used, given that each satellite data has its own characteristic. The time, the scale in time, how do we call it? We have the resolution, the time resolution. We have the periods on which we can have those data, and we have the accuracy of the image and the band, the type of the band, the accuracy on the band. So that's those kind of information that help us choose the image Sentinel-2 for that one. It's true that this can be more precise, more accurate with Sentinel-1, which is which have backscattered with radar element. But these are the first step to go through. Now, the second step is to try to see what are the information that we can retrieve from those elements, and then I'm sorry, I will leave the moderator, who is a code writer, to try to come out with this question. Please, Joseph, can you help me with these technical questions?
Thanks very much.
Thank you.
Very much, Rodrigo. Actually, so each scientific methodology has clear steps from the problem identification, specifying the location, calculating the proxies that refer to water, and so on and so forth, until the visualization of the results. So in the notebook, all steps are highlighted, and I've said it in the chat, and there's some contact for everyone here, from Rodrigo, who presented, and our team, our technical team, especially Edward Boama, who also is part of the call. Because for the sake of time, I should answer the question of how did Africa validate the product on water resource monitoring. So what we do, we first of all run the code. We take some few lakes or some few water bodies. We try to deal with our partners in the regions and give us some spatial temporal data on those water bodies. And we see most of the results were performing above 90%. Then you could say this is scientifically tolerable. It could be replicated from one region to another. So, and also we always trying to upgrade, to improve our codes, that what we do could serve better the continent. So it's a kind of continuous process, but you combine EO processing with the field validations.
Yep.
So thank you, Alice.
Joseph, if it is it possible to integrate, to just offer for the users the possibility to integrate or combine the specific indices or even algorithms used, of course, by Digital Africa to identify the water bodies, but in the better ways, means For example, we offer to the users to integrate an hydrologic model, for example.
Yeah, actually, these are feedbacks we have been receiving from several users, but we try to leave the notebook sandbox very generic. But if a user requests for use case, we can co-develop that notebook, and once successful, we share it under the folder called use cases, so that everyone could access them and use them. Edward could intervene because he was the one manipulating everything around. I'm lucky you around.
Yeah, thank you. Thank you.
Good morning, Edward.
Planis. Yeah, hello everyone. So for the validation, I think Joseph has actually explained all of it. Mostly there's content, especially the continental service that we developed. That one, we make sure that we work with our partners to validate the data for us. So at the end of the day, we're actually going to get some accuracies from the continental products that we are working on to get full data for us to be able to validate those works. But aside that, such as the notebooks that we are working with, normally we work with the users. So for instance, Rodrigo is the one on the ground and he actually understands what is happening there. So through the work that Rodrigo is doing, he can actually provide the validation and also the accuracy of the notebook, what the notebook is actually providing, whether it conforms to what is on the ground or not. So that's how we're actually working to validate those data sets that we have. We have on the platform and also the notebooks. So, Anis, in case there's a notebook that you're interested in, that we have to work around Tunisia, because you are on the ground, we actually help you to tweak the notebook to generate the result. And once it comes to validation, we'll be happy if you provide us with full data sets to actually help you to do that. So thank you.
Okay, thank you, Edward.
Thank you, Edward, and thank you, everyone, because we are running out of time. So let me acknowledge everyone here present to our weekly live session, especially Rodrigue, our presenter. It is a very interesting topic. We have several topics every week, a live session, alternative French and English. And for more information, you can reach out via our um, our website, eastwestafrica.org, our social media at East West Africa, and also on YouTube. Soon the video will be uploaded so that people who are not able to follow those steps or to attend would still do it online. And as usual,